I'm now going to toss this over to Mike Feinstein over at Digital Lumens, and he will be presenting on intelligent LEDs and an energy efficiency portfolio.
Okay, hopefully I did that well and everyone can see the slides. Chelsea, let me know if it's not working well.
I can see the slides, so you can just start the slideshow. Yeah.
Excellent. Okay. Well, thanks everyone. I appreciate you taking the time to come and learn about industrial load reduction, and we'll talk about how intelligent LED fixtures can play a significant role in an energy efficiency program. My name is Mike Feinstein. I'm the VP of Sales and Marketing for Digital Lumens. I'm just going to dive right in. The agenda today is we're going to give you a quick overview of different types of industrial lighting technologies, and then go into what I call industrial LED systems and how they're different than the existing types of technologies. These types of systems can give you up to a 90% lighting energy reduction, and we'll talk about those economics and how it happens. We'll give a survey of some of our large commercial and industrial customers and some case studies of some successful deployments, and then give you a little hint about the future of intelligent LED lighting. So first of all, some legacy industrial technologies. You're probably familiar with these, things like high-intensity discharge, HID fixtures, either metal halide or high-pressure sodium. These tend to have the highest operating costs. They, because of the nature of these technologies, they're not turned on and off very much, so they just tend to be on all the time. They also put out a lot of heat, and so in any kind of a conditioned or cold storage type of application, they're going to significantly increase the HVAC load. They tend to have to be relamped every couple of years, and in fact the lighting output degrades pretty rapidly during that 2-year cycle, so they tend to be over provisioned in terms of the initial installation puts out more light than you need, and then over time it gets down to be less light than you need. They also have a lot of hazardous materials in the bulbs, so you have to dispose of them carefully, and as I mentioned before, you can't turn them on and off very quickly. More recent are a series of fluorescent fixtures. First were T12s, and like all fluorescent fixtures, they have a warm-up period, so when you first turn them on, they're not at full brightness. You have to have time for warming up. They also can't be turned on and off very rapidly, so they tend to be on most of the time, even when they have sensors on them. We're going to talk about that in a minute. These also have pretty significant relamping and reballasting cycles that can be quite costly, and also the bulbs themselves contain mercury and have to be disposed of properly. It doesn't change much with the more recent fluorescents, T8 and T5 or T5 high output. Those are more efficient, but really have all the same kind of physical issues around warm-up times, relamping and reballasting. And again, they have mercury. And the T5s particularly don't have very good performance in colder temperatures, so again, for refrigerated or freezer spaces, those just don't tend to work very well. After that, there were just regular plain LED fixtures. We don't have a lot of information about the basics of LEDs. I'm assuming people are familiar with the general idea about LEDs. They're more efficient, and I think in the early days of LEDs, they weren't bright enough to really fulfill these industrial applications, but over the last several years, the LEDs have gotten brighter and efficient enough that now they can be more energy efficient, just on a pure wattage level, than even these high-efficiency fluorescent fixtures. But they're not significantly more energy efficient just on their own. You really have to couple them with controls and intelligence, which is what we're going to be focusing on today. Sensors and dimming and daylight harvesting, all these types of capabilities to really drive the energy savings, even versus fluorescent fixtures. So here's just kind of a rough comparison. I'm not going to talk through all these numbers. You can access the slides afterwards to look at them. But if you look at the legacy fixtures on the left, you can see the wattages, 450 or 250 watts. And then as the fluorescent fixtures, the T8s and T5s, those are more energy efficient generally than they get to LEDs. You can see there's a significant wattage difference. And that kind of comes into the annual energy cost. But even on the intelligent LEDs versus LEDs with sensors, because of the intelligence, those LEDs can actually be on less of the time, and we'll talk about how that works later, but that's what really drives that incremental energy savings. But if you look at kind of the energy cost starting way on the left with HIDs, $39,000 for this particular sample, down to $2,700 with the intelligent LEDs, they can, even though those LEDs are more expensive than, for example, fluorescent alternatives, the incremental energy savings are so high that you end up with a very good project payback. And if you look at the bottom line, a very significant difference in 10-year total cost of ownership. And that's how we would encourage people to look at these projects, not just on the upfront cost, because LEDs will definitely be more expensive than a fluorescent alternative in terms of an upfront cost. But once you start looking at those energy savings and they start kicking in year after year, you very quickly flip over and have a much lower total cost of ownership with LEDs, and particularly with the intelligent LEDs. So just a quick amount of background about Digital Lumens, the company that I work for. We're really the leader in this concept of intelligent lighting. We have a company with strong background in LED lighting, networking, and software, and all those elements come in together to make a very strong solution. The company has been shipping products for a while. We've won lots of awards. You can see some of them there. And we sell a complete solution of LED luminaires with built-in controls and intelligence. Together, that system can cut lighting energy use by up to 90%. And we've been particularly focused on the industrial environment and building very rugged and scalable systems for the large-scale industrial environments. And by that, I mean warehouses, factories, maintenance areas, manufacturing space, aircraft hangars, things of that nature, all focused on the lowest total cost of ownership. The solution has kind of three main components. There's the actual lights themselves that have sensors and intelligence built in. These are wirelessly networked together using Zigbee, so they're easily deployed. You don't have to run cables to every fixture. And then we have our light rules management and control software that centrally manages the whole solution, both in terms of configuration as well as gathering data from the lights, how it's performing, that lets you produce reports both for M&V as well as just for ongoing management and optimization. The basic premise we have is that you should be able to get 100% of the light you need for maybe 1/10 of the energy, and that energy savings comes from multiple factors. You've got just the wattage savings, as we saw in that earlier chart of the LED's light source versus the other more traditional light sources, but each fixture has integrated sensing, dimming, and daylight harvesting. And by doing it fixture by fixture, you get the most granular solution. You can be the most aggressive about how fast you turn the fixtures off, how it responds to ambient light. And by being aggressive, you can squeeze out more savings, and that really adds up. And we do that by having each fixture be smart and make its own decision about when it should be on, when it should be off, and how brightly it should be on or how fully it should be off for any particular situation. But we do that with centralized control so it's easily managed and without compromising the quality of the light. We've got a line today of basically three main fixture outputs, 13, 18, and 26,000 lumens, the different power outputs. They're basically the same architecture, just different size fixtures, different numbers of LEDs, all with the same intelligence built in. They each have our own custom-made sensor that's better than the off-the-shelf sensors that's on any other fixture, that gives you a much higher mounting height, up to 50 feet, and much better sensitivity to sensor events, occupancy sensor events. And we have one of those sensors built into every fixture, so we get granular control. We have different optics options available for these fixtures, so they can be either correct for a warehouse aisle, where you want to pump all the light into the aisle, or into open spaces like you'd have in warehouse docks or in like manufacturing areas. All of these solutions have wireless control built in with our light rules management software. All these fixtures have a 107,000-hour L70 lifetime rating. That's basically the useful life of the LEDs before the lumen output has depreciated significantly. That's a very strong number, 107,000 on hours. Keep in mind there's about 8,760 hours in a year. So even if the fixtures were on all the time, this is more than 10 years. And often our fixtures are only on 25 or less % of the time, meaning that the LEDs themselves are good for basically the life of the building. And all of these fixtures are backed with our full stem-to-stern 5-year warranty that covers all the components, the power supply, the sensor, the LEDs, etc. As I mentioned before, each of these fixtures has integrated occupancy sensors that are of our own, design. And each of these sensors actually has 3 individual infrared sensors inside the one sensor package. That's what lets us get to the higher ceiling heights and have no dead spots. Many of the off-the-shelf sensors have dead spots where if someone approaches from the right angle, it won't trigger the sensor. By having 3 overlapping infrared sensors, we cover up all the dead spots, so we have much better performance. Also, each of these fixtures has dimming built in, and you can fully dim it any percentage level from 0 to 100. Why does that matter? Well, for a couple reasons. There could be some parts of the facility where you don't want it to be pitch black, maybe right inside the doors when you're going from one room into the next, or for safety, etc. And so if your only option is fully on, fully off, and you don't want it to be pitch black, then you have to have fully on, and that uses up a lot of power. By supporting dimming, we can have fixtures be in a night light mode where there's some lights, you can see what's going on, but much less than full brightness, and our power consumption is pretty much proportional to the percentage of the dimming. So a 10% dimming is meaning only uses 1/10 of the power of full brightness. Also, when the fixtures are on, you may not need them to be fully on. If you only need 25-foot candles on the floor in a particular area and the fixture is bright enough that it can deliver 30, you can scale it down by 20% or so and end up only at 25-foot candles, and that again will save you that 20% energy. So being able to tune each light, how bright it is when it's on, how dim it is when it's off, and being able to change those throughout the day gives you just that optimal energy performance. And all these types of tweaks can save an incremental 10, 15, 20% energy. They add up. One of the questions people have is about sensors, like how much do they really turn off the lights? And if you've got experience with, fluorescent fixtures with sensors, you might see, well, they don't end up turning the lights off that much because most sensors have a, 15-minute is the default setting because you can't turn fluorescent fixtures on too frequently. But we measure actually, across different applications, much lower levels of occupancy, if you would, or how much we can keep the fixtures on. In cold storage, it might only be 15% of the time on average. In the loading dock area of a, like distribution center, it might be on 40% of the time. In ambient temperature storage, 30%. Manufacturing, 35%. Now, these are averages, and it does depend upon the application. These are also across the whole facility. So like in a manufacturing area, there could be some parts of the facility that are on 50 or 60% of the time, but then the back corners or the, that one area that's only used once a week could be on much, much less. And so when you're calculating the projected energy usage, you've got to do it across the whole facility, not just the busiest place. And that has a big impact between the occupancy level and the sensor timeouts has a big impact. This is a study that we did in a warehouse which had 25% occupancy. And let me help you kind of parse all this information. The top row shows what happens when the sensor on the fixture is set to 30 seconds. That means when someone triggers the occupancy sensor, the light goes on. It stays on while the sensor remains triggered as they're there. But after they leave, once they're gone for 30 seconds, the light turns off. Similarly for these other rows, 60, 90-second timeouts, etc. So with a 30-second timeout, if you have a fixture that's 25% active because people are around 25% of the time, you can see, that could be at $35 a year in, energy cost. with exactly that same occupancy pattern, if you change the timeout only, don't change anything else, you can see how that drives the energy costs much higher. Just going from 30 to 90-second timeouts more than doubles the energy consumption. You just, because the access is so infrequent or is so short in duration but relatively frequently happening, the lights don't get to turn off often enough. You can see the impact of longer timeouts. Keep in mind, fluorescents generally have 15-minute timeouts. And if you look at this data, that would mean that they're on virtually 100% of the time with this type of an access pattern. Now, there could be nights where the access pattern's less, so I'm not saying that the fluorescents never, ever turn off throughout the day. But during this hour of kind of typical activity during the workday, these fluorescent fixtures would almost never be off. And you can see that that drives a significant energy savings just from having the lower timeout period. Another way you can save with a different type of sensing is with daylight harvesting. Each of our fixtures has a daylight harvesting sensor, so when they're deployed in a space that's got skylights and has windows, each fixture senses the ambient light that's coming in and will individually dim to compensate so that you end up with a very even amount of light on the floor. And that's a constant and regular dimming, so if the sun goes behind a cloud, the fixtures will get slightly brighter, or the sun gets lower in the horizon, so it's just putting less light in, the fixtures will gradually get brighter. And we have reports that you can see here where you can see if we do not have daylight harvesting, you have that all those hills and valleys, if you would, that would be the real access pattern in the facility and how much energy it would draw. But then the purple at the bottom is showing how much energy is really used because of the windows and skylights. We're able to save all that incremental energy because of the daylight harvesting. And depending on the building and the application, you can save 25 to 50% sometimes of the lighting energy just from daylight harvesting. Again, that may not be throughout the whole space, because oftentimes the windows and skylights are not evenly deployed throughout the space. But in the areas where they are, you can save significantly and do it in a very even way, so you don't have these jarring changes from all the lights on to all the lights off, which might be typical of kind of earlier generations of daylight harvesting implementations. I'm going to talk for a couple of minutes about our Light Rules control software. This is the centralized software that both configures the fixtures by setting those active and inactive dimming levels, as well as the occupancy sensor timeouts, and then reports on things like energy consumption, energy costs and savings, how occupied the facility is, what the impact is of daylight harvesting. We also have a very unique what-if analysis that lets you test out what would have happened if you had different settings. How much more or less energy would you have consumed, so you can test out different settings that you might want to try to save incremental energy. If they don't work out, it's very easy to change them back. This gives you a view of some of the screens from the Light Rules control software. There's a centralized dashboard that gives you kind of aggregate information about the facility. Then you can drill down and look at individual rooms or groups of fixtures, all the way down to the fixture level. We also have a very nice scheduling capability that lets you have different types of settings. You might want your lights set up differently for the day shift versus the night shift versus weekends. Maybe you do cleaning on Friday nights. The lights can be set up differently then. They don't need to be as bright. Or you have, like inspection period where you need to have lights as bright as possible, and they all stay on for this hour. However it is, those are all different profiles. You can see profile management there in the top middle. The scheduling lets you switch automatically from one profile to the next according to a calendar. And the calendar can be, you can do all kinds of things to have different things every Tuesday, or have holidays different than other days, weekends different from weekdays, day shift different from night shift, etc. So being able to optimize how much light is actually being used in each part of the facility, so you have the right amount of light at exactly the right time, is another way to get incremental savings. In addition, Light Rules has all kinds of rich reporting capabilities about energy consumption. We can do reporting based on a facility map that looks like the actual building, so you can perhaps diagnose trouble areas or highlight problems or issues, or just see things like the occupancy overlaid over the map so you can see which parts of the facility, which aisles are busier, which areas are busier. That can give you very unique operational insight. All these things that you really customize the lighting so you can do different things for different types of applications, the docks different from the storage areas, etc. And they all drive incremental savings. We also have the ability to override all this automatic stuff. If you just want to turn on the lights because there was an accident and you need to deal with it, or there was a spill, you can just override any of these things and turn on the lights in the whole facility or in any area with some manual control. We also have the ability to integrate this into other building management systems and to pull some of the data out so you can integrate the energy consumption data, for example, in with a larger building management system. All these things together drive the total savings picture. So when you think about the savings you get from an intelligent lighting system, you can't just focus on the LED power reduction, the wattage reduction. That's obviously important, and all kinds of LEDs can do that. But you have to look at all the components of savings. There's what you get from the intelligence. That's a lot of the stuff we were talking about so far. The ability to get the operational insight lets you do fine-tuning and to optimize things, to squeeze out some more savings. Then there could be other things for the end customer. If this helps them qualify for a bigger incentive, that's a savings component. If the power consumption results in a smaller load on the HVAC or the chiller system, that's an incremental savings. Also, because these don't have to be re-lamped or ballasted, there's a maintenance savings. So when we do proposals for customers, we try to incorporate all these savings components into a total savings picture, which, as you can see, can be much more significant than just the pure wattage reduction itself. All of our products are very rugged and robust, designed for industrial environments. We've got many, many deployments. They're very well proven. We meet all the various labeling and certification things, including the Design Lights Consortium, which we'll talk about in a moment, all backed by our 5-year warranty. I'm assuming most people are familiar with the Design Lights Consortium, the DLC. They have a centralized testing and evaluation facility for qualified products. It's always up on their website. We were actually the first high bay LED product to ever be certified by them. Every product we make is on the DLC list. In fact, we don't ship products until they're on that list. That's a great way for you to qualify products to make sure that it's a quality product that's delivering the right benefits in order to qualify for any type of incentive you might offer. And this has been very well proven out in customers. We now have more than 500 large-scale installations. You can see some of the logos from some of our customers, and we're saving our customers more than $25 million and more than 250 million kilowatt hours per year across all of our deployments. If we zero in on the MIA region, we actually have more than 85 installations in this region, covering more than 8.5 million total square feet. You can see they're spread throughout much of the territory. Here's just a snapshot of some of those. You can see some of the customers that are in the MIA territory, and some of them, as you can see, have multiple deployments in multiple states across this territory in different applications. We also tried to do some estimates about what the impact of intelligent lighting could be on the whole MIA territory. So we've got some estimates of the amount of industrial energy consumption and some assumptions on that based on how much of that is lighting. You can see it state by state as well as the total. It adds up to about 91.5 million kilowatt hours per year in industrial lighting. And most of those lighting fixtures are on most of the time, as we talked about, because the timeouts tend to be long, etc. So there's an opportunity for very significant energy savings. And lighting is about 29% of industrial energy use according to the EPA, and therefore it is one of the fastest and easiest way to reduce energy consumption is to target that type of industrial lighting. From our analysis, the average installation saves about, for our customers, because they do tend to be more sizable facility, we're saving about 106,000 kilowatt hours per installation per per year. And that's pretty powerful because it's about the same amount of savings as more than 1,000 residential retrofits or 46 commercial office retrofits. Because of the size of the facilities, you basically have one decision maker making one purchase and one decision that saves a lot of energy. And we think if you're really thinking about how you can meet your energy efficiency targets, going after industrial lighting is a great way to save lots of chunks of energy with relatively fewer customer decisions. Each customer decision takes time. If you can get more energy and fewer decisions, you can more quickly achieve your energy reduction goals. So we've got a few case studies I'm going to talk through here. This is one of our early customers called Maine's Paper and Food. This particular site was in upstate New York, but you can see they actually have deployments in the whole red area is their kind of business area, and many in the MIA territory. This particular facility was almost 500,000 square feet. It was a combination of ambient cold and refrigerated spaces, 7 by 24 operation. They took out HIDs, which not only had horrible looking light, as you can see on the left, but actually were using tons of energy. So they actually doubled the amount of light in the facility from 9 to 20 foot candles. But while they were doing that, they still saved 87% savings on their lighting energy while they were doubling the amount of light. And that had less than a 1-year payback, partly because of the incentive that they had received. This was their first deployment with us. It was so successful that they've since deployed in every single facility they have, and any new facility they build, they automatically put us in because they've seen the amount of savings they can get. Another customer is Associated Grocers of New England, and I've been up in this facility. That, like before picture, I don't know how it looks on your screen, but it really was as dark as it looks. It was dangerous, I would say. They had about 380,000 square foot facility, which they put the lights in 56,000 square feet of cold storage on a retrofit. And they actually had fluorescents in there, but nevertheless they still were able to get $52,000 of annual savings and obviously increase the amount of light as well with a very nice payback on that project. Another customer is New Orleans Cold Storage. This was a new construction facility, about 142,000 square feet. Again, this was cold storage. They considered, rather than putting in intelligent LEDs, they had considered T5 fluorescent as the alternative. But when they analyzed how much energy that would have used versus the LEDs, it was about a 245,000 kilowatt hours annual savings, which certainly justified the modest incremental cost for going with the LEDs, since they had to buy either fluorescent or the LED fixtures. That energy savings more than justified the incremental cost. Another new construction site was down in Texas. This is a company called Benny Keith, almost 500,000 square feet, and they had a major sustainability initiative, which drove them to put the intelligent LEDs in. And this is one where their energy efficiency manager was considering using fluorescent fixtures as well, but the utility incentives that were available to them made them consider LEDs. And really very late in the project they decided to switch from fluorescent to LEDs while the building was already being constructed, and they ended up saving lots of energy because of it. So that gives you kind of a broad brush of a bunch of our potential of our customers. We've got one in the MIA territory that I wanted to zero in on a little bit more. This is a real estate company called Silver Beauty. They build and lease warehouses in the Chicago area. They're all ambient temperature warehouses. This particular facility is about 177,000 square feet. That's a 24/7. And they actually had 1,000-watt metal halide fixtures up in that facility. Those obviously use a lot of energy, but they were having problems. First of all, just the overall energy expense and maintenance expense, because they have to relamp these 1,000-watters. That was very high. The light levels were not really sufficient. Even though they had these very bright lights, the lumen output depreciates rapidly, and they couldn't maintain a sufficient light level. And the actual particular fixture that they had was humming. They couldn't get the manufacturer to figure out why it was humming, but it was such a buzz in the facility that actually all the workers were wearing earplugs all the time. That was a real, inconvenience. So what did they need? Well, they needed, higher levels of light in both their rack dials as well as the open spaces. They really wanted something that could go instantly on and off. Obviously, if there's any kind of a warm-up time, it really defeats the purpose of having sensors, because in a warehouse particularly, people are moving quickly, and the workers on forklift trucks can't wait for lights to warm up. They've got to be instant on and off. This facility has skylights and windows, and so there was a daylight harvesting opportunity, the ability to dim the fixtures down to take advantage of the ambient light that might be coming in from those skylights. They also wanted the ability to change the fixture settings. They actually rent out their warehouses to other tenants. So when a new tenant comes in, they may have different requirements. They're physically setting the facility up, differently. So the ability to reprogram the fixtures without actually touching them, being able to do it from their desktop, was very important. They wanted to get rid of that annoying humming noise. That was very important. And obviously they were going to look at the overall economics. They wanted to save on maintenance. They needed a good payback. They needed this to last a long time. They really didn't look at other options. As you'll see, they had gone to fluorescence in another one of their facilities that didn't really work out very well. So they ended up deploying Digital Lumens intelligent lighting in there, and they ended up getting 92% annual energy savings. Their lighting bill went from $78,000 to $4,000 a year. That's obviously very significant, and saving 1.2 million kilowatt hours a year, while keeping excellent light levels across the entire facility. And today, in their warehouse number 5, we're reporting about 30% occupancy in the well-traveled aisles. Keep in mind, this is an ambient warehouse application, and only 10 or 15% elsewhere. So you have to, again, you kind of average it out. They end up having about 20% occupancy or less across the entire facility. They're comparing this against a different building, warehouse number 6, where they did put in those T5 fluorescent fixtures with occupancy sensors, and what they found was that those things were really degrading rapidly because they were turned on and off relatively frequently, not too often, but even with the amount of cycling that they did, they found that it was lowering the lamp life. And they've even made an incremental investment in cold weather ballast, because this space is not heated or cooled. It's just kind of whatever temperature the outside is, it tends to be what they have. So in the winter, it gets a little cold in there. And they had made the incremental investment in those cold weather ballasts, but it didn't help them in terms of the lamp lifetime. At this point, I want to introduce Mark Allen from ComEd, who's going to talk a little bit more about some of the incentives that were used at the Silver Beauty application and what they're doing overall. So Mark, if you're still there, I'm going to turn it over to you.
Perfect. Thanks, Mike, and good afternoon, everybody. For my part, I just want to talk a little bit about the incentives itself, where the lighting plays into that for commercial and industrial incentives, and then also a little bit about custom applications, which, of course, with most of this advanced lighting, that's where these are going to come in for. First off, the difference between prescriptive and custom is prescriptive is more of a menu type choice. So it says that if you replace a T12 for a T8, for example, if we stick with lighting, you do a 2-tube fixture to a 2-tube, we pay you a set amount of money. So it's very easy, kind of just a pick, plug and play, very easy to calculate your incentive on all of those. And then the custom is basically, of course, you can't have a prescriptive incentive for everything, so therefore custom comes into play, those things that don't apply on every one of those calculations. One of the reasons that we try to do the custom is because, especially with advanced lighting, in this particular case with Silver Beauty, the lighting levels, not only were the occupancy sensors going to go in, but the amount of time that they're going to be off is also in play. So therefore, to get the maximum amount of incentive and claim the maximum amount of savings for that, we took that this process to the custom incentive. One of the issues with custom is because it is kind of anything that doesn't fit and anything that's not well defined, we need to help with some definition. And so the requirement for custom is a pre-application, and so that we have a chance to look at the current installation, take some meter readings, do some verification of the usages that are there, and then we go away, you finish your project. After the project is all complete, we come in on the back end and then also do some verification as well to make sure that everything that we said was going to happen did happen, and we can verify those savings. Now, one of the nice things that we had in this particular one is with the Light Rule software, some of the outputs that we're getting for that were very close for us to, and we can just verify those on our ComEd meter as well. So the software in this particular case worked out perfectly for us and was a really good connection and verification, again, for the ComEd. And with that, Mike, I will turn that back over for you.
Great. Thank you, Mark, and hopefully you can stick around for the Q&A in case there's some extra questions for you. I just want to talk for a moment about the future of intelligent lighting. What we've done so far is, already has lots of capabilities, but we would expect over time to add further customization, both other types of fixtures for particular applications, as well as incremental features for some new types of controls. All these things aimed at, reaching additional customer applications and making the system more flexible and more customizable. We're also looking at, integrating with other key technologies. I'd mentioned building management systems integration. The first thing that we're doing there is around pulling our data out of our system and having it easily pulled into a building management system that might be trying to tally up energy usage across a whole facility, across multiple system types. And I think longer term, you could expect us to have control the other way, where you could use a building management system to push configuration changes down into the light roll system as well. For customers that have multiple sites, right now we're really just managing each site individually with its own instance of light rules. But over time, you can expect that we'll have some kind of a cloud-based system where we can aggregate that data across multiple sites and give an enterprise-level facility manager visibility into how the systems are all performing together, how they compare against each other, and giving more of a global view. We've also done some testing of integrating with automated demand response for our customers that are participating in demand response, and where there might be an automated signal rather than having a more manual approach where there's a notification given to the customer that there's a demand event and asking them to cut their load. You can imagine this being done in a more automated fashion where a signal comes from the utility that's received by our system that could automatically adjust to a different lighting profile. We've already done some field testing of this type of capability, and if it becomes widely used, we could certainly deploy it. And over time, we're going to move beyond just the warehouse and factory type of applications that you heard mostly about today into all types of commercial and industrial applications, including things like parking, commercial offices. We see the general technology type that we have, the kind of approach we have, being applicable across all of these types of applications. I think we'll probably stay out of residential, but just about anything else is in our sites over time. And I think that the types of technologies that we have are really applicable to all those types of applications and can deliver similar types of results. If you think about the industrial end user, they are really busy. We're often selling to the facility manager. They don't have a lot of time to assess lots of different kinds of products and technologies. They definitely count on multiple people as sources of information, but their energy provider is certainly one of them. So having you guys educate customers about the possibilities is very important. I think for the customers to accept that this is a real reasonable solution that they should consider. Many of our customers have energy efficiency or sustainability managers, but most of them do not, and so they just don't have the in-house expertise to always evaluate these. From an economic point of view, they're really looking for projects that have a payback of 2 years or less. So having the right level of incentive can make or break that type of investment. And oftentimes we see projects wait until the incentives are significant enough for them to kind of get below that like 2-year payback. And of course, one other reason why customers could look at these projects is that in addition to just the economics, they're trying to comply with an overall corporate sustainability directive. And of course, sometimes they're on a pretty tight deadline, so we've seen these projects that can drag on for a long time, and then all of a sudden they become active, and then it has to happen quickly. So what can the utilities do to help support the deployment of this type of technology out into the market in order to really reap that very significant energy savings possibilities that we talked about earlier across the MEA region? Well, I think custom incentives, as Mark talked about, are very important. I think they tend to be more generous because they're really tied to the amount of real energy saved. And it's very important that these are significant enough that they bring projects to a 2-year payback period or something less than that if possible. And one of the benefits of systems like ours is that we've got very good reporting, so it makes the M&V process for those custom incentives much, much simpler. Something else that some utilities have done in other regions are to sponsor trials in order to really validate for yourselves the energy reduction that you get from these types of facilities, and then publish a case study around that, so that you've got a tool that can be used with other customers that's got your own data validated in it, so it gives customers the confidence. Anything you can do to train your own energy efficiency team or your trade allies in these types of new technologies is very helpful, and of course we'd be happy to help do that where it makes sense. And also, we've got so many installations across the MEA territory. We'd be happy to help, facilitate a site visit at one of our existing installations, just so you can learn more. That might be the appropriate next step for some of you. So that's really the end of my presentation. What we try to talk about is how we can combine efficiency, flexibility, and reliability to give you the maximum amount of savings. And I'll just point out that my contact info is on the slides there at the bottom. You're welcome to contact me after this with any other specific questions. I'd be happy to help you. So with that, I'll turn it back to the moderator who can lead Q&A session. Thank you.
Great. Thanks, Mike. And just a couple reminders. Both the webinar recording as well as a PDF of the slides will be posted at the midwestindustrial.org website. And please send your questions into the question box on the right hand of your screen, and I'll go through them with Mike now. So first question is, does guidance exist for calculating either deemed savings or custom thermal savings for an LED installation, which would be replacing incandescent, HID, or other lighting in refrigerated space based on overall thermal load?
We don't have any specific guidance about that, because it really is going to vary so much based on the type of heating system that is in place. Some of it's just about the building characteristics. So I've got no general guidance. I mean, it really depends upon the application, but we do have a team of application engineers that can help dig into a specific opportunity in order to help analyze it. I will say that in cold storage applications, this can have the biggest impact, and we've seen in freezers, for example, where we've done quite a bit of business in the earlier parts of our company's life, you can really get 25 to 30% incremental kWh savings. So if my lighting installation would save 1,000 kWh, you get another 250 or 300 kWh just from the reduced chiller load, because you're taking all that energy kind of out of the system. That's in a freezer. It obviously would be somewhat lower in like conditioned space. Another thing that comes up that people don't think about in spaces that are not conditioned, but in ambient warehouses, is if you've got HIDs up in the ceiling, for example, it gets really hot. Some of these, ceilings can be 120, 130 degrees Fahrenheit in the summer. And that can be uncomfortable for the workers. It can also lower the life of these lights that may not be spec'd for that heat. And just by swapping the lights, you end up lowering that ambient temperature because you're not putting as much heat out and using as much energy. All the energy that's consumed by these lights, whether it's given off in heat or light, eventually becomes heat. So if you just lower the energy load, you're going to lower that ambient temperature as well.
Okay, thanks. The next question is, it seems to be that one of the significant financial benefits for intelligent lighting would be demand and not just energy reductions available through demand response. Is there a reason these benefits weren't included in TCO calculations?
I'm not sure I fully understand the question. I mean, we certainly do much more than demand response. I mean, most of our savings comes from, kWh reduction in load. We can also calculate overall aggregate load reduction of kW because you not only have these lights mostly off, I should say, but you can look back and see what your peak aggregate load was. And sometimes there are incentives available for peak load reduction, and we can help calculate how that would be as well. Even though theoretically the maximum load is all the lights fully on, over time you can see that that really doesn't happen with these types of installations, depending on how they're set up. I don't know if I'm fully answering the question, though. I'm not sure that I understood the question fully, but hopefully that's a helpful start.
Another question we got was, can the same controls be used for T8 lamps you're using for the LEDs?
Right. So we don't sell our controls separately. All the controls are integrated fully into the fixtures currently. So we don't offer that ability to do controls on T8s. And as I mentioned before, with T8s, you don't have the dimming capability. You don't have the instant on-off capability. So a lot of the benefits you're getting, those incremental savings beyond the pure wattage reduction, comes from the occupancy savings, comes from the dimming. You can't do that with T8s. They don't dim. You can't turn them instantly on and off, and you can't turn them on and off too often, or you greatly lower their life. And so, in fact, even if physically you could, control the T8s, because you'd have to set them so conservatively, you wouldn't really get most of the benefits that I was talking about anyway.
Okay. So you got a couple cost or payback questions.
Mm-hmm.
One was, what was the payback of the Silver Beauty project prior to incentives, and what percentage of the project cost was covered by incentives, and also just a general cost range estimate per fixture, if you have that.
Yeah, well, it obviously depends on the fixture because we have different, like light outputs depending upon the amount of brightness. I think the fixtures installed tend to be somewhere from $800 to $1,000 fully installed with all the software and everything else included. In terms of the Silver Beauty, I don't have all the numbers in front of me in terms of what the payback was without incentive or what the percentage was of the incentive. I can say, so I can speak more generally about our projects. I think generally without incentives, the projects tend to have 2 to 4 year paybacks, and with incentives, they generally get pulled down to 1 to 3 year paybacks, depending upon the situation, and varies obviously widely depending upon the type of incentive. So, and as I mentioned before, most customers are really looking for that 2 year payback. That's the thing that really gets them to move quickly. And so that incentive can range from anywhere to 25 to 50% of the project cost, sometimes higher, depending upon the geography. But for Silver Beauty, I don't have this specific numbers in front of me.
Sure. In the future, will Digital Lumens sell controls or software to retrofit existing LED fixtures?
It's possible. We're certainly looking at that. Okay. We're considering it.
Okay. And I'm not sure if Mark is still on the line, but there was a question about incentive numbers from ComEd for offering the custom incentives for advanced lighting fixtures and controls. How much?
Yeah, so for all of our custom lighting, we offer our incentives at 5 cents a kilowatt hour for reduced savings.
And I could just comment more broadly. I mean, that's a pretty typical custom incentive program, very nice program. We really like those. And that would be kind of a typical rate of savings on those custom programs that we see nationwide. There are some that are somewhat higher, but that would be a pretty typical rate on a very nice program.
This is Jay Robles.
If I could just add for the particular one, on the Silver Beauty here, the cost of that was about, incentive was about 50% of the initial cost.
Thank you, Mark.
Okay.
So one question, I've had numerous discussions with both utilities and solid-state lighting manufacturers, and there's a debate whether a prescriptive rebate is better than a custom rebate, just because the prescriptive often gives you the exact dollar amounts that can go into sort of budgets. Can you guys talk briefly about the balance between the two with regard to solid-state lighting?
And we might have a different perspective, so I'll give you the manufacturer's perspective.
Perfect.
Prescriptive is nice because it is simple. As you said, you know going in, I'm going to save $50 on this fixture or whatever it is, so from a budget point of view. But we actually provide very good tools that make it easy to estimate the impact of the custom incentive because it's generally based on kilowatt-hour savings. We can do a pretty good estimate of those kilowatt-hour savings based on what we know about facilities and what the existing lighting is and what we think will happen when our lights go in. So we can do a pretty good estimate. And in fact, almost all of our projects that receive an incentive get a commitment letter from the utility in advance that gives that kind of verifies the estimate. I mean, it's not the same as writing the check. Someone's got to do the M&V afterwards, of course. But they look at the methodology and will validate that that seems like a reasonable approach and to give the customer some comfort that they're going to get that level of incentive. It is a little more complicated, obviously, than just the pure dollars per fixture, but oftentimes those are bigger incentives because I believe the utility is willing to put more dollars out because it's really in direct proportion to the actual savings achieved. Mark?
Mark, do you have any follow-up from the implementer utility side?
Absolutely. So, and Mike kind of hit most of the points already, but the biggest thing is prescriptive by nature is the easier of the two programs. It is, kind of a menu type choice. It's a lot easier for the customers. The downfall of prescriptive is the fact that it's in wide categories, and so therefore from manufacturer to manufacturer, exact lamp type to lamp type, so it's kind of an average. So therefore they are conservative by nature and not exactly what the savings are. And because of that, the cost is a little bit smaller. The rebates are a little smaller for the prescriptive side. A lot less work, a lot less hassle, and so therefore the rebate's smaller. With the custom pre- and post metering, so there are some additional costs that we know that are going to be incurred by the customer, so therefore we pay higher on a custom value. Plus we know then that it's kind of an exact number. It's not an average of all lighting in this type. It is this particular project. So it gives us a better number. So from our side, we don't really care which one. Both of them are fine. From the customer side, prescriptive is a lot easier. Custom, you usually get a little bit more money.
Okay. So there was a question on the expected life of the driver, and also can the driver be replaced when needed, or does the whole luminaire need to get replaced at driver failure?
Right, so that is a good question. So first of all, we do warrant the whole fixture for five years. That would include the driver and everything else. And we talked about the LED light output expected lifetime, the kind of how long until 30% lumen depreciation, which is a kind of official measure of LED lifetime. That's 107,000 on hours, which is an awfully long time. The fixture is modular, so it is possible to change the light bars rather than changing the whole fixture, but I would say it's often not cost effective to do that, just because the amount of labor that is involved. And so, for example, on the very small number of times where we've had a hardware warranty claim, we've tended to swap the whole fixture rather than just swap the light bar. I think we'll have to see how that goes over time for the longer term once we're beyond the 5-year warranty period. But it is designed to be modular, and so it's certainly physically possible to swap those light bars, which include the LEDs as well as drivers.
Okay, great. And I think that's going to conclude our session today. I know that it's a couple minutes past noon now. Thanks again, Mike and Mark, for being here with us. And again, the webinar recording will be posted to midwestindustrial.org/resources/webinars, both the recording and the slides. So thank you all for joining us, and you'll be hearing from me soon on upcoming industrial webinars on different topics.
Thank you, everyone.
Thank you.
Thank you.